All right, so let's look at another square root. Let's say our problem is square root of 10, and we need to estimate the square root of 10 to the nearest tenth. So first of all, we need to look at this and say, hey, brain, this is not a perfect square root. I know some perfect square roots. Let me think if I can think about what they are, right? So maybe you just put some numbers on a number line, and that might be something that you do, right? And you're like, okay, 1 times 1 is 1, so the square root of 1 is 1. The square 2 times 2 is 4, so the square root of 4 is 2. 3 times 3 is 9, so the square root of 3 is 9. And then you're like, oh, my goodness, look, square root of 10, that's going to be really close to the square root of 9. What about 4? Now, I ran out of room because I didn't plan ahead, but I can still, let's just put it on here and think to ourselves, right? That's going to be the square root of 16. 4 times 4 is 16. So I know then that the square root of 10 is somewhere in here. So I'm going to look at this little piece of the number line, and I'm going to expand that a little bit more. So it looks to, so I can see it's going to be between 3 and 4. So I'm going to make my number line right here between 3 and 4, because those are the, right? The square root of 16 is 4, and the square root of 9 is 3. And I can see that the square root of 10 is going to be really close to 9. The pen wants to keep rolling in here. All right, so it's going to be really close to 9. How close? You kind of have to think about what else is in here, right? Somewhere in here, so we have the square root of 10, right? Some square root of 10. There's going to be the square root of 11, the square root of 12, the square root of 13, the square root of 14, and the square root of 15. All of these non-perfect square roots are going to be somewhere between 3 and 4, right? So in here, if we think about our decimals, right, we have 3.1, 3.2, 3.3, 3.4, 3.5, which is halfway, right? 3.6, 3.7, 3.8, 3.9. So each one of these, right, we could square and find out what the decimal square root, that perfect like decimal square root, what it would come out to, right? But I can see that 10 is down in this part of the number line. It's towards 3. So it's probably one of these 3. And so in order to narrow it down, I want to think to myself, I'm going to pick 3.2 first. I just think that's a good place to start, and I can move on from there. So, right, when I say pick 3.2 to start, this is what we're going to start. We're going to check this one. We're going to check it. And so what did we do here, right? We took, to get to that 9, we said, well, what is 3 times 3? To find out this perfect square root, what did we think? We thought to ourselves, what is 4 times 4? So if we're going to check 3.2, that's what we want to do. 3.2, right, times 3.2. So 2 times 2 is 4, 2 times 3 is 6, placeholder, 3 times 2 is 6, 3 times 3 is 9, and then we're going to add that up. And now we have 4, 6 plus 6 is 12, carry the 1, 9 plus 1 is 10. There are 2 decimal places, right, and 3 times 3 is 9, so our answer should be close to 9, but a little bit more, so it is 10.24, right? So now I can see, if I put this on my number line, that the square root of 10.24 is 3.2. Well, guess what? That is more than 10, right? This is more than 10. So that means I need to find out, well, how close then is 3.1? So I need to also check 3.1. So this is, right? So once you know, right, that if it's more, right, if this is more than the square root of 10,